Astronomers estimate that there are, on average, 1.6 planets for every star in our galaxy. Some stars may harbor 2, 3, 4, or more planets, and others may have none at all, but overall, there are around 160 billion planets in our Milky Way galaxy. Exoplanets range in size from small, rocky worlds like ours to bodies that are more like stars than planets, huge, titanic gas giants, many times the size of our Jupiter. Finding these planets is difficult, and we have barely begun our search. Only recently have detectors sensitive enough to infer the presence of these bodies been developed, but we have begun to make progress. So far, we've found over 750 planets in orbit around 632 stars, and the Kepler Space Telescope has identified another 2,300 candidates awaiting confirmation. None of these planets have been seen directly. Their presence is inferred from the effect the planet has on the host star. Planets are very small compared to stars, and the blinding light emitted from them overwhelms our detectors and precludes direct observation. But astronomers are clever people and have found ways to see planets in spite of these obstacles. There are two major techniques that have led to our discoveries, and both are indirect. The first one is the method used by the Kepler Space Telescope, which is staring at over 150,000 stars in the constellation Cygnus and looking for minute dips in brightness as planets pass between Kepler and every star in the field of view. Known as the transit method, in addition to telling us that a planet is passing in front, it also gives us a good measure of its diameter, since larger planets block more light than smaller ones. The second method requires a spectrograph. It measures the pull of an orbiting planet on the star. As the planet goes around its parent star, its gravity pulls the star around, making it wobble. As a result, the spectrum of that star gets red or blue shifted as it moves towards or away from our detectors. We live in a golden age of astronomy. For the first time in our history, using our new detectors and instrumentation, humanity can begin to answer, through science, some of the most important questions about our universe. Among them, is anybody else out there? Are there any planets like ours nearby? On October 16, 2012, astronomers using the HARPS instrument at the European Southern Observatory announced the discovery of the first Earth-sized planet around another Sun-like star. And what's more, it's in the Alpha Centauri system, the closest stars to us. Specifically, the planet is in orbit around Alpha Centauri b, one of 3 stars in the system. Proxima Centauri is closest, followed by the binary system Alpha Centauri A and B. Located only 1.3 parsecs, or 4.2 light-years away in the constellation Centaurus, this planet is in our own backyard. Alpha Centauri b is slightly cooler than the Sun, with an effective temperature of 5214 Kelvin, and it is slightly smaller, having 0.9 times the mass of the Sun. Because it is a little smaller and cooler, its habitable zone, the theoretical distance a planet needs to be from the star that allows liquid water to exist, is closer to Alpha Centauri b than the one for us here in our solar system. Further, since this planet was found using the radial velocity method, astronomers were able to estimate its mass to be about 1.13 times the mass of the Earth, making this the smallest exoplanet found so far. But it wasn't easy to find. Planets the size of the Earth around Sun-like stars are particularly difficult and require unprecedented precision from the spectrographs, which HARPS was able to provide. because planets this size don't have much of a pull on its parent star. Here's why. This is the size of the Earth compared to the Sun. Looking at this, it's easy to see why our planet pulls only very slightly against the relatively titanic star it orbits. These effects are very small when trying to find Earth-sized planets, and therefore offers the most challenges. It is because this effect is so tiny that most of our first discoveries of Earth-sized planets will probably come from the stars closest to us. The close proximity makes it easier to see the wobbles of the star as the planet revolves, and allows our instruments to detect smaller variations. This effect is so faint that the wobble of Alpha Centauri b was measured to be only 1.8 kilometers per hour, about the speed of a baby crawling across the floor. While this discovery yielded the closest exoplanet to us, and it is the same size as Earth, the planet in orbit around Alpha Centauri b is hardly our twin. It orbits only 6 million kilometers away from the star and has a year of only 3.2 days, making it much too hot to support life as we know it. However, discoveries from HARPS as well as Kepler have shown clearly that the majority of low-mass planets are found in systems like this, giving us every reason to hope that there may yet be even more planets hiding in the closest star system just inside our celestial backyard.